We're from UNISA, and just a little bit about UNISA. It is one of the world's mega universities, and it sits with about 400,000 students. What is new at UNISA is it has set up a science campus in Florida. The labs are really state-of-the-art, and it also now has full-time postgraduate students in science and engineering, so we have masters and PhD students full-time at the science campus. Now, our institute is newly formed. It stands, as Hansi said, for the Institute for the Development of Energy for African Sustainability. We actually were formed this year after much paperwork. But we are a group that does both fundamental research as well as applying this. Now, our fundamental research covers a fairly wide range of areas. We cover reactor design, separation, process design to improve process efficiency, and we have a big team working in Fischer-Tropsch. We have about 20 staff members, that's including admin and technicians, and we supervise between 40 to 50 postgraduate students. But our vision is, apart from doing fundamental research, which is what we're quite well known for internationally, is to change the landscape by turning waste and other underutilized resources into fuel, electricity, and jobs through strategic partnerships. And we particularly aimed at working in Africa and the developing world because we believe the challenges are different there, the opportunities are different, and that this leads to different solutions. The material I'm talking about today is not just my work, it's all my colleagues, as well as all the students we've worked with over the many, many years, and so thank you to all of them. Now, as I said, we focus on demonstrating technologies. And we are mainly chemical engineers and biologists, and we're looking at environmentally responsible chemical conversion technologies. That's sort of the heart of chemical engineering. But where we see there's an opportunity is there is a lot of stuff we regard as a waste, which we spend an awful lot of money and effort trying to get rid of, but in fact could actually be an opportunity. And so we're talking about surplus and underutilized resources such as municipal waste and sewage and waste from industry. And where we also see an opportunity in Africa and the developing world is to move away from the mega factory approach, which is the current sort of paradigm, and looking at smaller solutions which are modular and flexible. Some of this is driven because once you start using alternative feedstocks, they don't occur in big piles like coal does and gas fields. You know, garbage dumps are big by our standard, but they're very small compared to a coal field. So you have to build plants to match the size of the resource, which means you have to go smaller, which again leads to challenges, but also leads to opportunities. Now, although we don't only work in informal settlements, we'll look at other areas. If we look at the situation in informal settlements, you get the informal settlements which are legally recognized, but you also get those which may occupy land illegally. In many cases, government is unable to provide service or unwilling if the settlement is illegal. So there's very often no adequate or at least an inadequate waste management system, and this leads to serious health and safety risks, especially in children. It leads to proliferation of flies, rats, which spread diseases. You end up with water pollution because the rainwater goes through the rubbish and goes into the rivers. So it ends up multiplying and actually causing a huge problem. This in turn leads to social challenges, and we are facing huge social challenges, as we've heard from previous speakers. In some cases, the inadequate sanitation systems causes health problems, and we work with our sister institute, who are mainly social scientists, who are based at Lenasia, the Institute of Social and Health Sciences. And this water pollution caused by inadequate sanitation is one of the leading causes for diarrhea in infants and death in infants. And not only in South Africa, but worldwide. And the communities in these settlements, they're marginalized economically and socially. Huge unemployment rates, 26% or so is the official one amongst youth, that's greater than 50%. And this leads to social unrest and a lot of justified unhappiness. Energy in these settlements and access to energy is always an issue. These settlements suffer from energy poverty. And a large proportion of their income is spent trying to supply energy for cooking, lighting, very simple, their simple basic needs. Sometimes this problem is solved. It's actually quite innovative. The illegal and unsafe connections, if you go and walk in Thembelihle, before it was electrified, it was absolutely amazing. I must admit, I think I walked around with my eyes skyward. I've never seen anything like it. If you see those engineers that we've lost to the system, but the way the system was engineered was absolutely amazing. Illegal, but amazing. Unfortunately, these systems is one of the major causes of fires and accidental electrocution. And so it really does lead to very unsafe working conditions. Now, we have waste, which is a problem, but I believe it can also be an opportunity. And I want to discuss the sort of vision that I have. Now, waste you can split into wet waste, and that would be your sewage, your food waste, animal waste, or the dry waste, which might be the plastics that you're throwing away in your garbage. It could be the waste from farming, your stalks. It could be your sawmill waste. Waste plastic is a fantastic feed, and yet it's a huge problem for us. The wet waste can be treated through digestion. And the dry waste, you normally have to go through a high temperature route gasification, and I'll talk about both of those more. But the end point is, once you've treated those, both of those lead to clean and improved energy. Now, let's just look at human waste. And excuse some of the pictures, but one has to laugh a little bit about this. We're looking for slogans for the various groups, and my slogan, the students kind of turned down violently. I said to them, because the group that works in this area, I said, why don't we have our slogan on the back of your jackets? We take your crap. Anyway, they didn't want that. They're looking for something more sophisticated. But nonetheless, this is what we're doing. Numbers that we've got in 2012, the world consumed about 5 times 10 to the 20 joules of energy. And sorry, I struggle with kilowatt hours. I like joules and watts. But we can always convert those around. Humans produced just under 1,000 billion kilograms of feces a year. There's an awful lot of stuff we've got to get rid of. But if you looked at this as an energy source and not a problem, you could produce about 6 times 10 to the 18 joules per year of energy from this, which is about 1/100th of the world's energy needs. Our sewage systems have not really changed from the 1850s, where it was first proposed. Flush them away and send them somewhere else. Somewhere else was first a nearby river, and then that worked for a while, and then it had to be treated first and then into a nearby river. But we haven't really changed the system from there. We don't regard it as a resource. We regard it as a health hazard and something to be get rid of. Other waste. Now, cows, depending if you're an Indian cow or a cow in a European or American dairy farm, produce somewhere between 30 to 50 kilograms of wet manure a day. It turns out that each cow you could produce about, depending again on the numbers, and these are quite conservative, 300 to 1,000 liters a day of biogas. If you look at a stove, a single plate stove, it uses about 50 liters of gas an hour when you're simmering. And so you could, from one cow, cook for 2 to 4 hours a day, quite conservatively, the waste from one cow. So if you look powered by waste, let's go now to a rural family. Let's say they need to cook on a 2-plate stove for 2 hours a day for cooking, and maybe they need to heat up about 40 liters of water a day to 50 degrees C for cooking and bathing or so on. One cow, together with the human's waste, could supply this energy quite easily. So, you're really not talking about really difficult. You have to have the way that the cow, or if you have 2 cows and they're in a shed overnight, then you've got, when you clean that shed out that night, you put it in the digester, it supplies your cooking needs. So, we really could look at, in rural areas, powering households, at least with their cooking and heating needs, on animal and human waste. And then you simultaneously solve the problem, because by doing that, you also sterilize the waste, the human waste, which also means you're solving an environmental and health problem. It has huge spin-offs. The kinds of wastes we can use in this approach is any organic waste. So you're talking about organic municipal waste, the manure, pigs, cows, chicken, sheep. There's lots in the literature which ones work, which ones don't. In our lab, they all work. And sometimes the sheep is better from Ondersteport and the sheep from that, but they're all kind of working. Grass, straw, hay, industrial waste such as bagasse, sawdust. All of these are possible feeds. So there's huge quantities of material that we can use in these digesters. The question is, why don't we utilize this waste? And sorry, this picture came up. We're doing the calculations with some of our interns. And they were doing mass and energy balances, and they were given this problem. And the one student said to me, why do we call them cows? We should call them power stations. I sort of thought that was actually brilliant. But it really is. So the question is, why aren't we using it if it's there and it's available? Is it technically difficult? And the answer is, from our experience, no. Once they're running, they're kind of fairly robust and they keep running. If they didn't work very well, the earth would long ago have been overrun by manure and waste from animals. Is it economically not feasible? It could be. We'd have to look. I mean, is it not robust? Is it social issues? Is it others? And what we've been very lucky in this issue is we've managed to pull a team together at UNISA. And so we're working with the social scientists who are working in the informal settlements around Lenasia, and they help us gain access and work with the community to understand their needs, their concerns. We have business as well in on this. We even have psychologists. They came to visit us when we were talking to the community about this, and the Professor Kitty came afterwards. She said, you guys really don't know how to sell. You need some psychology. So now we have some psychology students who also look at how does one sell these kind of concepts to the community? What are their concerns? Engineers, biotech, microbiology, and it really is a multidisciplinary team needed to solve this. Now, these digesters have been used large scale, and these are sort of pictures of large scale. They really can be very, very large. I visited one in China where it was attached to a pig farm, and it was absolutely enormous. I mean, it was this giant pig farm, and they were taking about 1/3 of the pig waste into these, but it was, huge. Now, the large-scale use of biogas, basically you take your livestock waste or your organic waste from the municipality, you send it to these big digesters, you produce the biogas, and those then go to generators, which go to electricity. You can use it for heat if there's a place that can use the heat, and you can also use it for transport because you can separate out the methane, and then you can run buses and so on these. And the byproduct from this is a biofertilizer, which is actually turns out to have a higher value actually than the electricity from what our sums show. And so therefore you can return this to farming, and so you start meeting and talking about looking after the food energy nexus. In South Africa, we haven't been wildly successful. There's lots of plans, lots of discussion. BMW South Africa wants to run its Roslyn factory on biogas. There's a proposal for a site near the airport. There's the city of Johannesburg has a system, but as far as I know, when at the last talk I heard, they were just flaring the gas they got from there because there wasn't a way of turning or using the gas once they had it into electricity and putting it back onto the grid. The buses aren't using it. It is possible. So there are difficulties with large-scale digesters, and we could ask, what is it? First thing is, transportation of waste is not economical. It doesn't make sense to load up trucks with manure and send them 20, 30, 40, 50 kilometers. You've got to think differently. You've got to have plants built where the waste is, and of the size where the waste is. The legal framework is really very, very tricky. I mean, we are trying to do some experiments on sewage systems, and it turns out we're just very lucky by chance that the Lenasia site is in a place where they've got septic tanks. They're outside the boundaries, and so we can intervene before we feed into the septic tank, and we haven't really broken the regulations. We can't do this in the town without causing huge problems. Policy support on biogas, and I'll be careful here because one of the issues is you need strong policy support, but while systems are developing, you also don't want too rigid a policy. But the policies are a problem. If the policies are a problem and there's not sort of much support from government, funding becomes a problem because bankers aren't particularly interested. The administrative processes are exceptionally complex, especially at municipal level. You know, if you're working with garbage, you're working with one department. If you're wanting to sell electricity back, you're working with another department. If you're wanting land for this, it's a different department. The legislation around waste is fairly fixed, so if you're trying to access garbage, it's really, really very hard. And then, of course, it's NERSA. Trying to, once you've got gas, it sounds easy, but trying to then sell the electricity back to the grid is a challenge all on its own. So all of these, I think, are problems. There are ways around this, though, and my belief is small-scale digesters, for all the various reasons we mentioned, actually get around these sorts of problems. And they are used in other parts of the world. India, China had very large-scale or large use of these. It's sort of disappeared again and might come back. The process is similar in that if you're on the farm, the farmer could feed their sewage, any food waste, animal waste, into the digester. And this picture here is an example of the digesters we've been using in the community. It's basically a large bag, double-walled bag, plastic bag, basically. You feed in on the one end, and then the slurry runs out on the other. And we've got some other pictures closer up on it. From the gas, which would be on the farmer's site, you can do cooking, and this is actually the wife of the first farmer. We put one on, and that's her cooking. She was actually most impressed. Lighting, also possible from these. They're generators that run off biogas. I'll tell you more about the first farmer we used, but for example, they use the generator. They've got a little river, and they pump the water up from the river when they need to irrigate. There's geysers, so they can do hot water heating. And the slurry overflow can then be used as a fertilizer. And again, just as an observation, when I went to visit this first site, we had a biogas digester on. I drove in, and the one side the plants were sort of this big, and the other side they were that big, and I thought, oh well, that spinach was planted a month or two before, and the other one not. And it turned out the one side had been getting the overflow from the biodigester, and the other side not. And you know, it was really very, very visible, even to me. The advantage, saving on fuel. The first farmer where we put it in, I mean, he was spending 300 to 400 rand a month on gas, paraffin. He doesn't spend that anymore.